So we've been graphing our trigonometric functions. We've been dealing with shifts in there. The only thing that we haven't looked at is when we're shifting our graph horizontally. And if we shift our graph horizontally, that is called a phase shift when we're dealing with our trigonometric functions. And so we're going to be graphing in this video functions in the form of f of x equals, so some coefficient out in front of our trigonometric function, sine. So a times, let's call it sine of capital BX minus C. And then let's say plus D. Or similarly, the same thing, but with the cosine function. So a cosine of BX minus C plus D. So we haven't dealt with that minus C inside of our argument before. And so recall, when you're dealing with some function, let's say f of x minus k or minus c, where k is a number that's greater than 0, then this shifts the graph of f of x to the right k units. Where if we had f of x plus k, where k is a positive number, this would shift the graph of f of x to the left k units. Okay, so that was a horizontal shift. And so that's what's going to be our phase shift, what's shifting it. And it really depends, because maybe this is not the number 1 in front of the x. And so our phase shift this is going to be our value of C divided by B. And if our value of C is greater than 0, then it's to the, it's greater than 0. It's going to be to the right C units. And if C is less than 0, we're going to move that A sine of BX to the, or cosine of BX, to the left C units. That coefficient of A that's in front of our sine or our cosine, that's still going to give us our amplitude, so how much we're stretching it vertically. This D, adding that constant outside of our trigonometric function, that's still going to be shifting our function vertically. And that B in here, this is still going to affect our period. And so our period when I do this, I'm going to normally use sandwich things in between my inequalities like we've been doing in the past. But sometimes we're going to be given information about our trigonometric functions, and we're going to need to find the equation. And so knowing these formulas are going to be helpful in that fact. But our period can be found by 2 pi divided by, in our case, the coefficient in front of x, which is b. And like I mentioned, our amplitude Amplitude only occurs where there are cosine and sine function. This is equal to the absolute value of A. So now let's go through and let's graph a couple of these. And knowing how to graph sine and cosine without that phase shift in there is just going to be really helpful to be able to graph these functions. So let's look at how about y is equal to 2 cosine of 3x plus pi halves. So the direction says find the amplitude if one exists, period, and phase shift of each function. Graph each function, be sure to label key points, and show at least 2 periods. Okay, so looking at this, I can see what my amplitude is. I have an amplitude of absolute value of 2, which is 2. My period I can find by taking my argument, which is 3x plus pi halves, and sandwiching that in between a normal period cycle between 0 and 2 pi. So just like we had done before, we want to isolate that variable in between those inequalities. And so we want to get x by itself there. And so first thing that we would have to do is get rid of that plus pi halves in between those inequalities. And we can do that by subtracting pi halves from each side. And so 0 minus pi halves, that's not too bad, is negative pi halves, is less than or equal to 3x, which is less than or equal to, well, 2 pi minus pi halves. I need a common denominator there. So my common denominator is 2. So that's going to be, multiply that by a fancy 1, 2 over 2. So that's 4 pi halves minus pi halves. That's 3 pi halves. I need to get the x by itself in between the inequalities, and I can do that by dividing everything through by 3, or so I don't have to deal with complex fractions. Let's multiply everything through by 1/3. So I have 1/3 times negative pi halves, so that's negative pi 6, is less than or equal to 1/3 times 3x is x, is less than or equal to, so 1/3 times 3 pi halves. Just for now, let's leave that where I don't reduce the fraction, and that will just help us when we're looking for the length of the period, so we have a common denominator. So 1/3 times 3 pi halves is 3 pi 6. So I have to go and I need to figure out what my period is. And I can figure out what that period is by looking at this length between negative pi 6 and 3 pi 6. So my period is going to equal my larger amount, which is 3 pi 6, minus my smaller amount, which is negative pi 6. So actually I'm adding 3 pi 6 plus pi 6, which gives me 4 pi 6. And so let's write out our period is equal to 4 pi 6, but we're going to reduce this. It's just easier to keep a common denominator when we're going to go through and mark out multiple periods. So I'm going to keep it as 4 pi 6, but I'm also going to reduce it. They both have 2 in common. 2 goes into 4 pi 2 pi times, and 2 goes into 6 3 times. So 4 pi 6 is 2 pi thirds. So we have our amplitude, we have our period. We actually have our phase shift. Our phase shift, notice, is negative pi 6, about negative pi halves. No, sorry. I was correct when I first said that down here. It's this negative pi 6. So our phase shift is negative pi 6. Which, if you followed that formula, that was C divided by B. C in our case, which was pi halves, just showing you get the same thing, all divided by B, which is 3. So pi halves, and it was opposite. This should be minus and negative because this is a plus in here. Phase shift, or when that form was bx minus c. So in here, this would be a minus and negative pi halves. So this would be negative pi halves. Divided by 3 is the same thing as multiplying by the reciprocal. So times 1/3. So negative pi halves times 1/3 is our negative pi 6 here. So we could have plugged it into our formula, but again, I think it's easier when we're going to have to graph these things is to figure out what the start and the end cycle of one period is. And we can do that by sandwiching that argument in between a normal period of 0 and 2 pi for all our trigonometric functions other than tangent and cotangent. Okay, so we got all of those important values. Let's start plotting what we have. And so actually, before we do that, we have our start value of one period, which was negative pi halves. So we have a start. Not negative pi halves, negative pi 6. And we got our end value of 4 pi 6. And so we want to find our halfway mark. So to find the midpoint, recall you add your values and divide by 2. And so the halfway point, let's just do some work over here on the side. We're adding our values. So negative pi 6 plus 4 pi 6. And we're dividing by 2. Or same thing as multiplying by the reciprocal, which is 1/2. And so negative pi 6 plus 4 pi 6, that's 3 pi 6. So 1/2 times 3 pi 6, which gives us 3 pi 12ths. So now I need to find my quarter-way mark. And so my quarter-way mark, again, we're going to look at the midpoint, but now we're looking at the midpoint between the start value, which is negative pi 6, plus the halfway mark. I'm going to leave a little room because I'm going to need a common denominator, which is 3 pi 12ths. And multiply that by 1/2. So common denominator would be 12. And so this would be 1/2. Negative pi 6 is the same thing as negative 2 pi 12ths, multiplying that by 2/2. Plus that 3 pi 12ths. Negative 2 pi 12ths plus 3 pi 12ths is pi 12ths. And 1/2 times pi 12ths, that gives us pi over 24. So our quarter-way mark is pi over 24. So these aren't as easy as some of the ones were before when we didn't have that phase shift in there. And so that 3/4 mark we are going to take the halfway point, which is the start of our 3/4 mark, which is 3 pi/12, plus the n value, which is 4 pi/6. And multiply that by 1/2. So we need a common denominator. Multiply 4 pi/6 by 2/2 to get 12 in the denominator. So we have 1/2 all times 3 pi/12 plus 8 pi/12, which is 11 pi/12. So 1/2 times 11 pi/12. Which is 11 pi over 24. Okay, so we now have the start and end value of one of our periods. We know what our amplitude is, we know what our phase shift is, and so we can now graph this. So let's mark those values on our graph. So we have negative pi/6. We have pi/24. We have 3 pi/12, 11 pi/12, and 4 pi/6. Not totally to scale. We know we have an amplitude of 2. There's no vertical shifts. And so our max is going to be 2, and our min value is going to be -2. I have a cosine function. So normally I start at the max, which I do because there's no reflection across the x-axis. My coefficient in front of cosine is +2. So at negative pi/6, I'm going to have 2. At pi/24, so I'm going to hit the x-axis. At 3 pi/12, so I'm going to hit -2. 11 pi/6, hit the x-axis, and then 4 pi/6, I'm going to hit 2. And so we could find the other values to continue on and do another cycle. I know I'm out of time, so I'm going to stop there. But what you could do is you could figure out what this length is between negative pi/6 and pi/24. And that's what you're going to be adding to get from our endpoint, which would be the start of a new period, to our quarter point. So in the halfway point, keep on adding that, and that would give us those values. And you would do it the same way that we were just doing to find those important marks. So that is sum of or half of 7.8 in our textbook, which talks about phase shifts and sinusoidal curves. So we'll finish this lecture and start jumping into chapter 8 on Thursday.